One of the things that frustrated me enormously when I was ill with fibromyalgia is really struggling to find the words to explain just how utterly bone deep exhausted I was. And I used the word exhausted so often that it really began to lose any meaning. So when I came to the chrysalis effect and I was given the answers as to actually what was happening in my body why I was so exhausted, it was really quite a revelation. And it took me back to my nursing training and the physiology, the biochemistry I did. And it suddenly made perfect sense. So I want to explain that for you today. And I want to begin with looking at what your normal energy metabolism should be. So if you remember back to your days at school, you might remember learning about the mitochondria that are in every cell in your body, and that these are the powerhouse of the cell. So this is where your energy production happens to produce the energy that your cells need to function. And what happens is that the blood brings glucose from the gut to the cells, and it combines it with the oxygen that's come from your lungs, also via the blood. And glucose and oxygen together, there is a chemical reaction which creates energy. But that gets disturbed when you are in a chronic state of stress. And in a previous video, I've talked about this chronic stress and its widespread impact on the body. And one of the effects it has is to actually reduce the number of mitochondria in your cells. So the effect of it is like if you suddenly knocked out a large proportion of your internal power stations, you are functioning on a much lower level, with much less energy production. And the molecule that is at the heart of energy production in those mitochondria is called adenosine triphosphate. And if you can think about it, I like to use my fist as an example just to demonstrate how this works. So ATP is a molecule of adenosine which has 3 phosphates attached to it, and they are attached by an energy bond. So 3 energy bonds attaching 3 phosphate molecules. And that stores the energy in the molecule until it's needed. And when you need the energy, what happens is that there is a process through which that energy bond is broken, and one of the phosphates is removed, and the energy is released for use. And what you're left with is called adenosine diphosphate, and di standing for 2, because you've only got 2 phosphates left, each of them storing energy in the bond. And what's supposed to happen is that this molecule is recycled. So the body will bring another phosphate molecule, and attach that to the molecule with another energy bond, and therefore it's ready to go again the next time it's needed. And obviously this is happening billions of times in all of your cells every day. So what happens to go wrong in that process? Well, if you think that there's an awful lot less ATP in your body when you have fewer mitochondria, you run out much more quickly, and you find yourself in a situation where you can't recycle. So you've got your adenosine diphosphate with the 2 bonds, but the demands on your body are such that you haven't got the resources or the time to actually recycle this molecule. So instead of adding that phosphate molecule on, your body will actually use the remaining 2 energy bonds that are holding on those 2 phosphates. And that leaves you with a totally destroyed molecule, which is of no further use. It can't be recycled. And so what happens then is it takes a couple of days before your body is actually able to renew its supply of ATP, because it has to build it from scratch. So you have a day on which you need to do more, you put much more demands on your body, you use up all your ATP, and you go into that reserve backup process of breaking down your ADP, and that will get you through at the time you think you're doing fine. But actually then it will hit you later with a wallop of having no energy at all. And that makes it quite difficult sometimes to connect why you're tired, if actually the thing that you've done is a couple of days earlier. So this process helps to explain that time lag. And the other thing that's going on when you go into this backup process of breaking down the ADP for energy is that it's a process that is anaerobic. And that means that it occurs without oxygen. And one of the byproducts of an anaerobic process is lactic acid, and that builds up in the cell. And you might be familiar with the name lactic acid in terms of the cramps that you get if you do a lot of exercise, and that it builds up in your muscles and creates pain. Well, it's the same thing happening in your cells here, that the lactic acid builds up and you get that awful achy feeling. So I hope that's helpful in understanding both why you are so exhausted, that it's not all in your head, that it is actually something that's going on right down at the cellular biochemical level, and that this lag between using energy and actually having the crash that follows it also has its roots in biochemistry, and it is not all in your mind. So I hope that's helpful for you. If you found this video helpful, please do click on like below and subscribe to my channel. You might also like to hop across using the links to my Facebook or LinkedIn pages, where you'll find much more content.